Hey Warren, I thought I would just go ahead and record a little video for you here and help you with this. I believe this is the problem that you're looking at. I went into your My Math Lab uh, section here and I pulled this up, and it seems like this is the problem you're working on. So I don't know how to use that Windows 10 calculator if it replicates a TI-84. So whenever I need to do something like this, I just use Excel. So let me show you how this works very, very simply. Uh, so the data looks like a number of years after 2000. That variable is represented by T, and then the percentage with only wireless phones is represented by P. So actually, you want to think probably in kind of an XY relationship here. So you're using T and P. So the first thing you need to do in order to find this regression line, the easiest way to do this is build a scatter plot. So basically, this is two-dimensional data. So you can build a little scatter plot by doing the following. So if you just highlight the data that you want to see in your scatter plot, and you go to Insert, and in these charts, there's this, if you see what I'm pointing at here, this allows you to build a scatter plot. It's just kind of an XY, it looks like an XY first quadrant of the XY plane, and then a bunch of dots. So obviously these ordered pairs represent your data. While these are the ordered pairs, this is the graphical representation of that data. In order to find this regression line that you're looking for, if you just right-click on any one of the ordered pairs and then go to Add a Trend Line, you're going to get this little box that pops up over here. What you want is a linear model, and then if you go down to these options down here, one of them says Display Equation on Chart. So if you click that, that'll give you, let me get this out of the way for you. This gives you the regression equation, meaning, what is the line that best fits this data. So that's a little out of the, for now, when we talk about differentiation, there's an element of that helps you find this equation, basically the line that kind of minimizes the distances from the points to the line. So this line looks pretty good. But you see the equation, this line is y equals 4.1x minus 15.6. Or in your terms, it would be percentage with only wireless phones as a function of years after 2000. So that's your y and x here are T and P here. So you see here y equals 4.1x minus 15.6. That's the answer that you're going to get here for the coefficient of T and then the y-intercept. So that will give you that question. Then the estimate of the percentage of adults living in households with only wireless telephone services in 2016. So at this point, what you want to do is you want to use this equation, y equals, or actually P equals 4.1T minus 15.6. 2016 is 16 years after 2000. So what we're going to do is we're going to take this equation and we're going to substitute 16, since you're talking about 16 years after 2000, and see what the estimated percentage of people using wireless phones would be. So the math on that would be if you just hit equals and then 4.1 times 16 minus 15.6, and it looks like it's about 50%, and that's the number they're looking for here. So I hope this is helpful. I apologize. I've never been a TI user because it's to me it's not very friendly to use, and if you're using a big data set, it's not very friendly to work on a big data set. So this will get you down the road with what you need to do in terms of understanding how to attack a problem like this. So I hope this is helpful. If not, give me a shout back. Thanks.